Hey everybody, it's time to graph. Grab some graph paper. If you are in my classroom, grab a whiteboard that has the grid on it, the coordinate plane, so we can get to plotting and graphing some exponential functions with an asymptote. What's that? We're about to find out. All right, so we just finished up the chapter on sequences and patterns, and we know that the 1 is the y-intercept, or the start, or the 0th point, and we just go ahead and plot that. The pattern is times 2, so after 1, we're going to go times 2 to 2. We're going to go times 2 to 4, times 2 to 8, and then we're off the screen to 16. If we want, we can make a table where we plugged in 0 and got 1. We plugged in 1 and got 2. We plugged in 2 and got 4. We plugged in 3 and got 8. We can see that we're starting at 1, and the pattern is times 2, times 2, times 2. We learned that when we have sequences and there's an n or a t of n or an a of n or an s of n, that means we only plot the points. We do not connect them. Same thing down here, same pattern, same starting point, but because it's y equals, we would connect those. So on the black one, I would go ahead and connect these to make my exponential curve. So what was that vocab that Mr. Z wrote at the beginning? What is an asymptote? What does that mean? Well, let's think about this pattern. This pattern was times 2, times 2, times 2, times 2. So if we went backwards, we would divide by 2. So this 1 would divide by 2 to a half, divide by 2 to a quarter, then to an eighth, then to a 16th, then to a 32nd, then a 64th, and then a 1 over 128, 1 over 256. We are at like the smallest decimal that we can get to is like where we're approaching. An asymptote is something that approaches a number, gets really, really close to it, but my graph probably isn't perfect here because this should not be touching the x-axis right here. There should be a little gap all the way through that. That's what an asymptote is, where it keeps approaching a number. It gets really, really close to it. So these asymptotes on the graphs are going to be approaching 0 if I went backwards in the table and kept dividing 2, dividing 2, dividing 2. So we just plot points and just recognize the starting point and the pattern. And then the asymptote part is just get really close to 0, but don't touch it. All right, so what do we got here? We got in the green one, we got a sequence, which is just the points. It starts at 3. You can make a table if you want. You double it to 6. You double it to 12. That's off my screen. So maybe I want to go backwards here. Cut 3 in half, and that is 1.5. Cut 1.5 in half, that's 0.75. So that would be the green graph right there, the green equation. And as I'm doing the black one, it's a y equals, so I get to connect those. So in between 3 and 6 is 4 and 5, and in between 6 and 12 is 7, 8, 9, 10, 11, and 12, and 11.1, and 11.2, and 11.3. So I'm connecting those for my exponential curve. And as I go backwards, I should be doing this asymptote where I get really close to 0, but I don't touch it. All right, let's go ahead and start off with the black one here. Starting point at 10. That's easy enough. Y-intercept. If you plugged in a 0 on that, you would get 10. If you plugged in a 1 here, you would get 5. Why? The pattern is multiplying by a half. If we cut that in half, the 5 would go to 2.5. If we cut it in half, it would go to 1.25 and 0.6 something and 0.3 something, and we would get to connect those because it is y equals, so our exponential curve, this would be decreasing, this would be exponential decay, and I shouldn't touch 0. I know my graph looks like it does, but I should not touch 0 because it is an asymptote. If I was graphing the green one, I would just plot those points and I would not connect them. It would only be those points of the pattern or the sequence. 10 would be in the pattern, 5 would be in the pattern, 2.5 would be in the pattern, but there would not be a 9, an 8, a 7, a 6, a 6.1 in between those. So I would just plot those green points if it was listed as a sequence like S of n. All right, we've got a of n. If I'm going for the points, I'm going to start at a 4, and it is multiplying by a half, so that's going to go down to 2. and then to 1, and then to 0.5, and then to a quarter, and then whatever past that. If I want to go backwards, this is dividing by 2, or sorry, let's stay with what it is. It's multiplying by 0.5, so if I wanted to go backwards, I could just divide by 0.5, which is the same thing as doubling. If I'm dividing 2, dividing 2, dividing 2, then I could multiply 2 to get up to 8, multiply 2 to get to the next point, 16. If it's y equals, I just connect those, and when I connect those, I get to draw in or get a better idea of that asymptote, getting really, really close to 0, but not touching. All right, in the black one here, we have an exponential equation. We are starting at 4, and we are multiplying by 1.5. So if I multiply by 1, that's still 4. Then a half of it is 2, so 4 and 2 would get me to 6. I went too far there. Would get me to 6 is the next point. If I did 6 times 1.5, well, 6 times 1 is 6. 6 times a half is 3, so 6 and 3 is 9. If I did 9 times 1.5, that would be 9 times 1, which is 9. Half of 9 is 4.5. 9 and 4.5 would be 13.5. I'm just going to go ahead and write it up there. Cool, if I wanted to go backwards on this graph to help me get that asymptote, I'm just going to divide by 1.5. So 4 divided by 1.5, I'm going to get some weird decimals here as I'm dividing by decimals. It's 2.6 repeated. And then if I divide that again, I'm just grabbing my calculator, it's 1.7 repeated. And if I divide by 1.5 again, it's 1.1 and some other stuff. We can see our exponential curve, and it has that asymptote, which is approaching 0. I'll go ahead and write that again here for the vocab. That P is silent. It's an asymptote. Asymptote. If I was graphing the green graph, the green sequence, it would just be starting at 4, going 1.5, going 1.5, going 1.5. If I wanted to plot the points backwards, I could, but I would not connect that graph. And let's go ahead and finish it up. We got g of n, probably for geometric, starting at 3. Let's divide by 2. That goes to 1.5. Let's divide by 2 again. Let's divide by 2 again. I'm just approximating at this point. If I want to go backwards on my graph, I'm just going to go ahead and multiply by 2. Do the opposite of the pattern. So 3 will go to 6. 6 would then go to 12. All right, if I'm graphing the black one, we'll finish off with this exponential function. This one is a function down here. All the black ones have been functions as they have x's and y's. They're connecting in between the points. All the green ones have been sequences, which are just those points. It's discrete, it's disconnected. But if I'm graphing the black one, that is a y equals. I can go ahead and connect all those points. And it helps to draw in that asymptote that approaches 0 but does not touch it. So hopefully you learned a new vocab today, asymptote. We did a bunch of practice because we did everything twice. We just saw that this really connects to sequences, and all we do is connect the dots. The end.